everybody, and welcome to my channel. I am very grateful today to you all for taking the time to be here in this session. This session will be about the teaching, our teaching philosophy and our teaching statement, and we will take the course description of robotics engineering as an example. The course of robotics engineering is considered as one of the important topics today, along with artificial intelligence and system integration to make life better. I am Dr. Fawaz Fathi Taha, Muhammad Assistant Professor in Oman Islamic University. So our outlines for this session will be as following. First of all, we will talk about our general teaching philosophy that can be applied for this course and also other courses. The general information about this course. Then, what are the references that we will use in this course? The program and syllabus, the outlines for each modules and chapters, then the objectives and outcomes that we are expecting at the end of each module, at the end of the course. Then we talk about the assessment philosophy and how we can evaluate students fairly and effectively. And finally, we will consider we will consider the grading topic, which is related to the assessment philosophy. Okay. So, what is our teaching philosophy? Okay. First of all, we want to make sure that we are developing and updating the outlines and details of the content of any course by comparing and matching them with high standard resources, such as the syllabus and program of top-ranked universities worldwide, because the science is distributed among countries like other resources. Also, consider the job requirements, the advertised job requirements of the top companies in the field. Also, we consider the research outcomes of high impact papers. And finally, the teacher experience, the teacher field experience, okay, because in order to ensure the students has a great understanding, we want to provide first to the student a whole picture of the systems that are used in the industries. Okay, so we will consider using a top-down approach. So firstly, we need to see the whole picture, and after that, we will go deeper in the details rather than starting by details and making the student lost during inside these details. Okay. So for the content, we make sure the content is plentiful with about a full chapter for every 2 lectures. Okay. And to motivate the teaching environment, we mostly we dedicate the first two lecture, the first two lectures to be about the course description and overview, because as we said before, we are trying to provide the students a whole picture, okay, to know about the current challenges, the applications, the problems, the research outcomes, because the course, in this course, we will learn the tools that are needed to solve these problems. So we are seeking to provide the students the right methodology to choose the right tools for related problems. Okay. Finally, to make the teaching and assessment and evaluation environment more interactive, supportive, and collaborative, we also we provide students illustrative pictures, videos, simulation programs, and so on. Because if the slides, for example, this slide contains 100 words, the pictures contain, one picture may contain a thousand of words, and the videos will contain maybe millions of words, and also the simulation programs may contain more than that. Also, we make sure that we provide the students the chance to share their ideas, their stories, to make the teaching environment more interactive. So now let's take a look at the general information for this course as example. You can see here this general information here contains summarization of the course. So we have prerequisites, we have aims. Aims is a general objectives. Okay, we have some tools, simulation tools, or maybe hardware tools according to the situation. So we have prerequisites before starting this course, because this course will give you the motion in free space, so we need to learn a linear algebra, vectors, matrices, and so on. Because this course, the robotics, is considered as a part of feedback control discipline, so we need to know about feedback control. We have to know some, we gain some knowledge about it, and in order to implement the information, the technologies, the algorithm, any algorithms, we need some programming skills. So what the aims, the main aims is we want to teach the kinematics of manipulators and their control. Okay, so what's the kinematics? The kinematics is a science of the robotics motion without considering any causes. The causes is an advanced topic, which is the dynamics. Okay, so for this course, just we are concerned about the kinematics. Okay, and we will take some overview about other topics, but the dynamics is advanced topics that mostly will be learned in postgraduate level, along with advanced topics in mobile robotics, under actuated robotics. The under actuated robotics is the robotics um, that has a number of joints is less than the required degree of freedoms. And degree of freedoms is the its ability to move in all axes, okay, in all directions, in any positions and any orientation. Okay, so in general, we have 6 degree of freedom. We have movement in X direction as a position, X direction, Y direction, Z direction, and also we have rotation about this axis, X, Y, and Z. So we have 6 degree of freedom. If robot has less than that, like for example, a two-wheel robot. Drones has four actuators, and we want in order to move these drones in 6 degree of freedom in 3D space. We have to make some maneuvers also for mobile robots with 2 wheels. We are controlling two wheels. We have 2 actuators, and we want the robot to move in 3 axes. Okay, so mainly our aims about analysis and design, to make some trajectory planning and to find the reference input and the reference command to the control system. Finally, to implement with programming, some programming tools. Okay, so in this course we'll deal with some simulation tools. Almost all we have some knowledge about MATLAB. We will use MATLAB Robotics Toolbox of Peter Cork, and we'll use Robotics Operating System or Robot Studio. The Robot Studio is a simulation environment for developed by ABB for their products, for their robots. And the ROS, Robotics Operating System, is operating system and that is running above Ubuntu operating system. With ROS, you can, for example, develop a robot from scratch or integrate with existing robotics such as ABB or Fanuc and so on. So let's talk about in this moment. I want to show you some of the capabilities of the Robot Studio, because here we have fixed manipulators like this. So we can see here our Robot Studio. This environment may be similar to our a high degree to the real environment. We have here 6 degree, 6 joints. Joint 1, okay, joint 2, 3, 4, 5, 6 at the wrist. First of all, we can jock this robot with this teach pendant in XY direction. Okay. Yeah, the XY direction is here. X, Y, Z. Okay. You can go to the jocking options here. Linear. X is the down arrow. You can hit this button to move the robot in the X direction, the Y direction, and the Z direction linearly. Also, I can move each joint independently. I can choose the first 3 joints, joint 1, 2, 3, joint 1 with the down arrow. This joint 2, here this joint 1, you can see just joint 1, joint 2, and joint 3. joint 3, yes, here it is, here this joint 3, you can see this joint 3, and also you can move other joint 4, 5, 6, 4, 5 and 6. Also I can just make reorient. As we said before, we have 6 degrees of freedom as a position, linear position, positioning in XYZ, and also rotation, orientation, reorient the movement around XYZ. For example, here this the blue color here is for Z. If I want just to reorient around Z, you can see here we have some orientation around Z, orientation around Y. We make some orientation. The position is fixed, but we have some orientation around this green line, and so on. Also, we can go to the program editor, example here, and we are trying to move the robot according to this program to follow this path. Okay, we have a lot of commands here. This Rabbit programming language is considered as a high level programming language because each instructor here, it contains a lot of a low level instructions and a low level algorithms that we have to learn during this course. Have a move linear, move circular, move joints. Okay, these the points, the velocity, the zone. So we have two options. If, for example, for the zone, if you choose find, the robot will stop and then resume its movement. If I want a continuous movement, I can make some zone with some radius. Okay, here you can see here we have some of continuous movement. Okay. Okay, I think now we have some great feeling and great understanding for this fixed manipulator. Now we can resume our slides. Now we have to take a look about these references, which is based on about high standard resources. You can see high standard references worldwide, such as this robotics modeling plan and control for Siciliano, Italian scientist. So the Spong, the reference of the Spong robot modeling and control, and this reference is widely used in top-ranked American universities, along with Introduction to Robotics for Craig. Also, we have some useful and high standard references that modern robotics mechanics planning, which is also used in high-ranked universities in the United States, and Springer Handbook, which is a joint effort between Osama Khatib and Stanford universities, and also Peter Cork of how to use MATLAB. Also, we are using syllabi and programs of these universities worldwide: America, Stanford, Roma University in Italy, British Columbia in Canada, South Florida, and many thanks to Osama Khatib, to Professor Osama Khatib, to Professor Alessandro Di Luca, to Dr. young cow and the Professor Ridwan Al-Qasimi, because usually we utilize their resources and research outcomes. Here you can see the general outlines of this course. Okay. Here some of subtopics. You can hear some subtopics inside each modules. Okay. And here we have the objectives and outcomes. Mainly, the main objectives and outcomes of any engineering course is firstly to understand, secondly analysis, and thirdly design, and finally to implement. So as we can see here, we have overview, then hardware and software components, then here are some foundation for rigid motion and spatial transformations, because we will use this foundation to analysis, to make analysis, to find the relation between the joints, the angle of joints, and the pose, the position and orientation and end effector, and then the design process, inverse kinematics, at the positioning level and at the velocity and level. Then we have to take a look at trajectory planning. If we have a plan, path plan, for example, we want to find at each segment the velocities at each sampling time, okay, and the velocities at each sampling time represents the acceleration profile, and we have to take these information as a reference input to the controller, to our controller, kinematic control. Okay, so with the kinematics science, we can build a robot with accepted performance. But if we want the robot to, for example, carry a heavy weights with a high speed, so we have to take care of the dynamics. Okay, so we have to take care of the dynamics, or the objectives and the outcomes. And here finally we have to consider our assessment philosophy, because here because we provide the students a lot of information, we are not just make a test for the students and memorization, but we are seeking to test their understanding and applied abilities and capabilities. So we support the students with, for example, multiple choice questions, and the students can see the answers, the choices as choices, and also some analysis for some analysis and design problems. Also, we provide the students some auxiliary tables and equations, and finally we seek to direct students to implement a mini project. Okay, so the students can use, for example, ROS, Robotics Operating System, okay, as a tool, for example, or Robot Studio, or make integration between them. Because with ROS I can build the robot from scratch, or I can use, for example, to integrate some external sensors like computer vision. So I can, for example, make interfacing between ROS, and I can use ROS as I can use ROS as a development environment to develop, for example, with the computer vision, visual servoing, okay, and develop drivers at ABB Robotics and make a communication between two. And here we have some grading tutorials, labs, mini projects. Mostly the grades will be about 30%, but at the, for remote learning, we try to make this as 50% to evaluate the students more closely, and the final exam be 70 or 50% according to this situation. And thank you very much for taking your time at this session.